To the tutorial on solving systems of equations by graphing. So let's begin with a quick review on how to graph using y equals mx plus b or our slope-intercept form. So you remember that the number with your x is your slope, the top number of our fraction is our change in y, and the number on the bottom is the change in x. And the constant, the b in our equation, is the y-intercept, where our line is going to cross the y-axis, and that number does not have any variables with it. So when we're talking about systems of equations, there's going to be three possible outcomes of solving these problems. We'll have one solution where it's an intersection of lines, and the lines in the system are going to have different slopes, and that's going to cause them to cross each other, and our solution is going to look like a ordered pair, an x comma y. Another situation would be possibly having the words infinitely many, and this is where the lines in the system have the same slope and y-intercept. So when we graph these lines, these equations, they're going to end up being the same line. So our solution is the words infinitely many, because any number that we pick that works with our first equation is going to work in the second equation, or third equation, or fourth equation. If all of the lines end up being the same line, then obviously they're all going to work in all the cases. The last one would be no solution, and our graph is going to look like parallel lines. This is lines in the system have the same slope but different y-intercepts. And you remember the definition of parallel lines are lines that never cross each other. So that would be no solution, because any ordered pair that works in one equation isn't going to work in the other equation. So let's begin with our first practice problem. And let's talk about graphing. We have y equals 4 over 3x plus 3, and y equals negative 2/3 x minus 3. So on the first one, I'm going to use purple. And we're going to begin by going to our 3 on our y-axis and putting our dot there. We know our line is going to cross at that point. And then by reading the slope, we can figure and determine what our line should look like. So 4 over 3. So that means I can either go up 4 and to the right 3, or I can go down 4 and to the left 3. With this particular ordered pair, that's what I'm going to have to do. Then go down 4 and over 3. It kind of goes off the line, off the graph, but that's okay. So I'm going to connect my dots. And that's my first equation of this system. Now I need to graph my second one. I'm going to use red for it. So we're going to begin this one at negative 3. And the slope this time is negative, meaning it's going to fall as it goes from left to right. So to demonstrate that, I'm going to go up 2. And this time I'm going to go to the left 3. Put my dot there. Up 2 to the left 3. Again, it kind of goes off the graph there. That's okay. Now, I didn't draw a very good line there, but I can see where my line should have crossed that It should have been at this point right here. Now, since my lines are not parallel and they are not the same line, that means my answer is going to be one solution. It's going to be that point where they should have crossed, and that would have been -3, comma, -1. So that's my solution for this first system of equations. -3, comma, -1. Let's go ahead and move back to our next system of equations. We have y equals -2. I'm going to let that be black this time. And y equals -3x plus 1. So now if you notice, our top line does not have a x. But that's okay. We know that it should cross the y-axis at -2. And since we don't have any x, that means that our slope for that equation, zero slope. Zero slope means that it doesn't rise or fall at all. It means it's just a horizontal line. So that's what I need to draw. I need to draw a horizontal line at y equals -2. My second equation, I'm going to use purple. And I'm going to start at 1. And my slope is negative, so it's -3 or -3 over 1. So I need to go down 3, and to the right 1, down 3, and to the right 1. Connect my dots. Again, not the best straight line there, but you can get the idea. And we can see at what point our lines cross. This dot right here. 1, -2. So since our lines intersect at a single point, that's our solution for this system of equations, 1, -2. Now sometimes you're going to get these problems that they're not already solved for y. So we need to go ahead and change our second equation there to make it into a, move things around so that we can have it in slope-intercept form so that we know how to graph this line. So I'm going to write down this equation, and I'm going to begin by moving my x over. My -5x needs to go over to the other side. And the way I do that is performing opposites. So instead of subtracting 5x, I'm going to add 5x to both sides. So -5x and plus 5x is 0. That's gone. I bring down my 4y equals, and I'm going to go ahead and write it in 5x and keep my negative sign on the 16, -16. Okay? So now I need to get y by itself. So I need to divide by that 4. Do the opposite of multiply by 4. Divide by 4 on every single term in this equation. So 4 divided by 4 cancels out. Y equals 5 over 4. Since we're graphing, we can just leave that as a fraction. X And then negative 16 divided by 4 is negative 4. So that is my other equation. Y equals 5 over 4x minus 4. So once I get both of my equations into a form that I can graph, I can already look and see, all right, both my lines had the same slope. You can see that right here. And then I can also see that they have different slope intercepts. So if you remember from a while ago, lines that have the same slope but different y-intercepts are parallel lines, and the answer is going to be no solution. But to make sure that you can really visualize this, let's go ahead and graph these. Let's do the top one as red. And we're going to go to negative 2 on the y-axis and put our dot there. And our slope is positive 5 over 4. So I'm going to count up 5. 1, 2, 3, 4, 5. And over 4. 1, 2, 3, 4. Alright, so normally you would want more than 2 dots to graph your line. However, we really don't have that much room on this particular coordinate plane. So we're just going to go ahead and go with these 2 dots. And go off the graph. Alright. And for our second equation, we're going to use green. So it goes to negative 4. And the slope is 5, so 1, 2, 3, 4, 5 over 4. 1, 2, 3, 4. And if you graph these correctly, you'll see, hey, those lines are parallel. They don't cross each other. They don't appear to be like they're going to cross off my graph or anything like that. And that confirms that it should be no solution. So this last set of practice problems, I picked 2 problems that were not solved for y yet. So we'll have to work both of these out. Let's do negative 8x plus 2y equals negative 2. Begin by doing the opposite of my x's there. I'm going to add 8x to both sides. So bring down my 2y equals 8x minus 2. And then I want my y by itself, so I'm going to divide by 2 by every term in my equation. So 2 divided by 2, we get y equals 8x divided by 2 is 4 over 1x, and negative 2 divided by 2 is negative 1. So that is my first equation rewritten in a way so that, hey, I can graph that. We have 3x plus 3y equals 12. So I'm going to start with my x's, do the opposite of plus 3x or positive 3x, and do minus 3x on both sides. So 3x minus 3x is gone. 3y equals negative 3x plus 12. And then in order to get y by itself, I'm going to divide by 3 on every term in this equation. So we get y equals negative 3 divided by 3 is negative 1 over 1x, and 12 divided by 3 is 4. So now I have my two equations ready to be graphed. I've got y equals 4x minus 1 and y equals negative x plus 4. So we'll use blue for our top equation. We're going to go to our negative 1, put our dot there, and our slope is 4, or 4 over 1, so we're going to go up 4, to the right 1, up 4, to the right 1. Obviously went off the graph there, but that's okay. Going to do the best we can to do a straight line. In the second graph, I'm going to use red. I'm going to go to 4, and my slope is negative 1, or negative 1 over 1, so I'm going to go down 1 over 1, down 1 over 1. I'm going to connect these dots. And even though my lines aren't the greatest, we can tell that they intersect this point right here, which would be 1, 3. So that's the solution for this set of this system of equations. So that's the tutorial on solving system of equations by graphing. Pretty soon I'm going to have up the substitution and the elimination ways of also solving for system of equations without having to draw a graph. So I hope to see you on the website again. Thanks.